So the question is 1 plus 3 plus 9 plus 27 plus ... equals 364. How many terms in this sequence are required to equal 364? Well, there's a couple of ways you could do this. The first way is ad hoc, and that just means just tap them out and see what happens. So here it won't take long. This would be 1 plus 3 plus 9 plus 27. Each subsequent term is 3 times the previous, so the next one would be 81. That's 3 27s. And then 3 of these is 243. Now that, it's not going to be another term, so it's at least, it's either here or here, isn't it? Equals 243, 324, 324, 325, 328, 337, 357, 364. So it equals 364. So you could do it the ad hoc way. There's nothing wrong in principle with doing that because you've answered the question, unless it specifies a particular method. 1, 2, 3, 4, 5, 6. So 6 terms are needed. The algebraic way to solve it, so that's method 1, and then method 2. Here Sn is a r to the n minus 1 over r minus 1, isn't it? That's the sum of n terms. We don't know what n is. We know the first term a is 1, so I'm going to put that in here. So a is 1, so let's just overwrite that now. R is, the common ratio is 3, isn't it? Because we're timesing by 3. So wherever we see an R, we're going to put a 3. So let's do that then. Okay, so this is 2 here, and we want the sum of 364. This is 2, isn't it? So I'm going to scratch this, just cheat here, scratch it out of the thing. 3 minus 1 is 2. And then 1 times this bracket term is just the one lot of the bracket, which is just the thing inside the bracket, so let's just write it like that. So let's move the 2 up to times, so we'll move that up from divide to times. Again, I'm just going to use the same line because I haven't got much room here. And it's nice to keep everything on the page. So move the 2 from divide to times now. So I'm going to do that. Of course you'd write this over several lines, wouldn't you? And then we can move the 1 over, can't we? Move them 1 across the equals. So 3 to the n is equal to 364 times 2, which is 6, 7, 28. And then move the 1 over, so add 1 to both sides in effect. So that's 729. And then what you can do is you can take logs, can't you? Because i.e. 3 to the n is equal to 729. So this is the equation in indecimal form as a power with the exponent n. We can change this by just dropping the 3 down and changing it to log form. So the 3 swings down, so n goes down to ground level, the 3 swings down and it's log 3 of 729. And that's how you go from logs to indices. So if you were to reverse this line, the 3 would swing down, hit the n in the end, you get 3 to the n, and that equals 729. That's how you unwrap the log. So you can go from equation in this form very easily to equation in this form, and then swing it back up, hit that in the air, 3 to the n is 729. So you can either write it in this form, they're equivalent, logs and indices are one and the same thing, just written in different forms. So that's what we want to type in then. So that was just a log question really. Log 3 is 729 on the calculator. So here's the log, base 3 is the number, and then we want 729, don't we? Toggle forward up to the box there. 729 equals 6. So the answer is 6. So we just worked that out there, haven't we? And we get 6. So you can take logs, of course, and do it log base 10 if you want, and do that, and then you'll get the same solution. But this is the shorter more succinct way to do it. So there are 6 terms, either by this method, or ad hoc, or by using the algebraic group.